Hi everyone, I'm Wenli. I introduced the definition of independence of X and Y. And if they are not independent, there exists relationship between X and Y. So we calculate covariance and correlation coefficient, right? Today I'm going to continue a little more about the correlation coefficient, and I'm going to emphasize precaution of correlation coefficient. Let's see. So the example is here. Given the joint probability distribution of the working hours and wages on the table is coming up, next page. We proceed to calculate the correlation coefficient as follows. Okay, X has unit hour, Y is wage unit dollar. Let's see the table. Here is the example. This one, X has unit hour. This one, Y has a unit dollar. So from the joint probability distribution given like this, okay, like this, simple example, then we can calculate the first covariance and correlation coefficient, right? So first, from this table, we get expectation of X 3.2, EY 160, variance of X from this table 0.96, variance of Y is 2,400. Okay, covariance X and Y is X expectation of what? Deviation of X times product deviation of Y, like this. 3.22, 160, already we get it. Okay, it's mean, Y is mean. So for four values, for pairs, 2 minus 3.22 times 100 for this. Okay, this pair. 100 minus 160 times its probability, 0.3. 2 minus 3.2 for here, 200 minus 160 times its probability, 0.1, add others. Then that will be 28. What is it? Unit of this covariance? Hour times dollar, right? So we want to eliminate this unit by standard deviation of X and standard deviation of Y. Variance X is 0.96, variance Y is 2,400. Then correlation coefficient get 0.583. Get it? It this one is a little complicated, I think, but it is not that hard. But how to get sample correlation coefficient? Previously, the definition of correlation coefficient pertained to the population for random variables. Okay. Now let's examine how to sample correlation coefficient is calculated when we have sample values for x, y, such as x1, y1, x2, y2, xn, yn. Okay, and sample size. For a sample, the covariance is calculated as this way: x deviation, y deviation, product, sum of them, divided by its what? Degrees of freedom. Degrees of freedom here, n minus 1. And standard deviation are calculated as this way for x, for y, respectively. Therefore, sample correlation coefficient is calculated as follows, like this. This is a formula for a sample correlation coefficient. Okay? Simple example. We get 4, 7, 6, 7, 11, 13. Sample size 3. Then calculate the mean of x, x what? Deviation, product, y deviation. It will be 6 to 16. And square terms, 9, 1, 16. Y, not 4, 4, 16. So you may calculate correlation coefficient 0.959. If you use computer will give you this kind of value, correlation coefficient. But we need to have some idea about the precaution of a correlation coefficient. Why? Let's see this one. There are various types of correlation. Simply obtaining and using the correlation coefficient can lead to error. If you have some result from computer, correlation coefficient, you should examine following precautions. We should examine first whether it is appropriate to use the calculate correlation coefficient based on the scatter plot of data. So it is important to see scatter plot of data. First, as mentioned earlier, Pearson's correlation coefficient is meaningful. That is correlation coefficient, Pearson's correlation. Okay? It is what? Linear relationship. When the data have a linear relationship, it is useful. Pearson's correlation coefficient is useful. It does work. If x and y have a parabolic relationship as shown like this in figure, the correlation coefficient will be close to zero. Okay? That formula, correlation coefficient formula for all this type of data. So actually this way, totally for this data. So that value, correlation coefficient, will be close to zero. Okay. Data, something like this, then correlation coefficient close to 1. Data like this, then correlation coefficient close to -1. Okay. If data something like this, then correlation coefficient is close to 0. That's why x square and y correlation coefficient will be close to what? 1. Because its shape is parabolic. Okay? Second, even with the same data, dividing the data for analysis can result in a completely different correlation coefficient, such like this. For instance, okay, for all this data is x is score, y is say IQ, okay? Then between exam scores and IQ in the general data set, all data set, it is high positive correlation. But for the scores 320, greater than 320, this data will be like this. Okay, will be like this. Then the correlation may not be the case when only high scores are used as data. Make sense? Although there may be a low correlation coefficient indicating no relationship between math and English score. This one is math. This one is English score. Entire group of students. For entire group of students means this way. This all data. Very close to 0. But data is divided by female and male. This data is female student, and this one, these are for male. Then you get different result. Okay, when data is divided into female and male students, the correlation coefficient for each group can yield large values. This is close to +1. This group, female group, shows you -1 relationship. You understand that? So I think you have to get a scatter plot when you analyze, when you get correlation coefficient. Okay, significant results can be obtained depending on how the groups are divided. So what I think you get what precautions are. Okay, okay, let's get some time. Okay, let's stop here today. Thank you. Bye.